Hi, I'm Pieri and I'm an astronomer at the Institute of Cosmology and Gravitation at the University of Portsmouth. Today I'd like to tell you about the biggest explosions in the universe since the Big Bang itself. Normally we think of galaxies as pretty, peaceful spirals of billions of stars like this one, the Cigar Galaxy. But if we look more carefully with our telescopes, we can see that in reality it's a cauldron of activity with an enormous galactic explosion occurring as we watch. When this explosion happens, the stars themselves don't get thrown out, but the gas and dust do. We think that these explosions come about when many stars explode together, when gas falls onto a supermassive black hole at the center of the galaxy and gets kicked back out, or when light itself pushes the gas and dust out. We can perform sophisticated computer simulations like this one that show how explosions from individual galaxies occur. These galaxies don't live in an isolation of empty space though. They live in a truly gargantuan cosmic web of gas and galaxies, as you see here. There is gas everywhere in the universe. Even the most remote regions of the universe are not really empty. This gas, which makes up most of the normal everyday matter in the universe, is known as the intergalactic medium. These massive structures don't just sit there looking pretty either. Explosions from galaxies reach far into space, as you can see here, bringing with them hot gas and elements born in stars. They stir things up and change the way that stars and galaxies form. But how do we see all this activity? The gas rarely glows enough to be seen, and often we can't see the galaxies either. They're too faint and far away. Instead, we can look at bright sources of light in the background called quasars and learn about this gas by what happens when light passes through it. Now, white light isn't as boring or as simple as you might think, nor are prisms just good for making really cool album covers. They show that white light is made of a range of colours, called its spectrum. The background quasar I mentioned a moment ago has a spectrum of colours like this. Here we will ride a packet of light from this quasar. This light leaves the quasar early in the history of the universe, and so passes a long way through the universe and most of its history to us on Earth. We can see how the gas of the intergalactic medium absorbs some of the light along the way, telling us many things like its temperature, density and composition in the elements like hydrogen, carbon and oxygen. Occasionally the light passes through a galaxy, telling us even more. A spectrum like this gives us an enormous amount of information about this melting pot of cosmic activity. Thank you for your time.